What I want to do now is give you a real brief review over some of the basics of complex numbers. Now, I'm doing this with the mindset of you've already looked at complex numbers in the past, you've been introduced to them, and you just need a brief review. So that's my perspective here going forward. Now, when you think of complex numbers, probably you think of this, I. I equals the square root of -1. And you may think of this, a plus bi. That's, a standard way we write complex numbers where we have a real part and we have an imaginary part. So maybe 3 plus 2i. That would be a complex number with 3 being the real part and 2 being the imaginary. And probably the first time you encountered complex numbers in a practical way was in solving a quadratic equation like this one. And you probably broke out the quadratic formula. And what happens is this part under the radical, b squared minus 4ac, whenever that's less than 0, you end up with that I, an imaginary part to your solution. So let's look at an example. Okay, so I plug into the quadratic formula what I need to. Okay, here it is. Put in the parts. Okay, now notice I've got 1 minus 4. Well, that's negative square root of 3. And when I'm trying to take the square root of -3, that's definitely going to give me an imaginary number. That's going to give me the I. So I rewrite the square root of -3 as the I square roots of 3. And I get this as my solution. I got -1 over 2 plus or minus square root of 3 over 2i. So I have a real part, -1/2, imaginary part plus or minus square root of 3 over 2. Okay, so now just some more information about I and powers of I, whole number powers. Let's suppose I've got I to the first. Well, that's, of course, -1, square root of -1. What about I to the second? What if I multiply both of these by I? Or what if I square both sides? Okay, square this side, I've got I squared equals -1. Then what if I multiply this, both sides, by I? Well, I get I cubed over here and I over here, so I get I cubed equals -I. And then if I multiply both sides by I again, I get I to the fourth equals -I squared, which -I squared would be -1, which would be 1. Now, this is important. This I squared equals -1, that's very important for you to remember because it's from a practical sense. You're going to be using that one a lot. But let's notice that we could keep going talking about powers of I. I could say I to the fifth, I to the sixth, and so forth. But notice that if we did that, what would happen is we would just continue on this cycle. We would go through a cycle of I, -1, -I, 1. I, -1, -I, +1. Yeah, I may have said -1. I meant +1. So that's what would happen. We just go through these cycles. So we can reduce any whole number power of I to one of these, either I, -1, -I, or 1. So let's look at an example. Let's suppose we have I to the sixth. Well, okay, so here's I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth. We end up with I squared, which is -1. So what I'm saying is this thing right here should equal -1. Now look, what happens is, you can think of it this way. You're dividing 6 by 4 to see, okay, how many complete cycles of 4 do I go through? And it turns out I go through 1, see? 1. And then I go through a half of another, 2/4 of another. See right here, 2/4. So what we do is we look at this 2 and say, okay, this reduces to I squared, the remainder, which is -1. See? 1, 2, 3, 4, 5, 6. And I end up right there. Or I could say 6 divided by 4, I go 1 full time, and then half of another. So I end up right here. So let's look at another one, I to the ninth. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8. I went through 2 complete cycles. Because 4 will go into 9 2 complete times, but then 1/4 of another. So right here, I to the first. So this is equal to just I. You could do that same thing with I to the 27th. See? So dig this. There's one full cycle, 4, 8, 12, 16, 20, 24. 24. And then 3 more. 1, 2, 3. See, 3/4 of another full cycle. So this is I to the third, which equals -1. So when you're talking about powers of I, that's how you can reduce them. It's a matter of recognizing that there is this cycle of 4. And mainly, from a practical sense, remember, this I squared equals -1. That's what you really need to remember more than these others. Remember that one. I squared equals -1, because later on, when you're working with polynomials and working with roots of polynomials, that's going to be an important concept for you. Now, just a reminder about some of the operations. We can add complex numbers. Notice if we have something like this, we just add corresponding parts. Okay? Add the real parts, add the imaginary parts. Subtraction. You always have to be careful when you have subtraction, because you want to be sure you address every term. So this minus applies to that 4 and this -5. So this would be, let's see here, 2 minus 4, -2, 3i plus 5i. See, this minus and this minus make a plus. We've got multiplication, and that's just like we always do multiplication. You multiply through, distribute each term in this complex number to each term in this one. See, just distributivity. Or you could call it FOIL if that's what you fancy. But you end up with 8 plus 2i minus 15i squared. And here's what I said. I squared should be replaced by -1. So this -15i squared is -15 times -1, which is a positive 15. Add like terms, and we get 23 plus 2i. There. So just some reminders about, how these operations work. Now, also remember, we sometimes see a situation like this where we have a complex number in the denominator, and maybe we want to rationalize that denominator. So what we do is we multiply top and the bottom by the conjugate. So if I multiply by 2 minus 3i to the top and the bottom, what I'm going to get up top is just going to be 2 minus 3i. But remember, when we multiply a minus b times a plus b, what we're going to get is a squared minus b squared. In other words, a minus b times a plus b will give you a squared minus b squared. Now, we have these complex numbers. I probably should have put a parentheses around here, but anyway. So here's what you have. You have 2 squared minus 3i squared. So that's 9i squared. Now, I squared becomes -1. So this is really going to be 4 plus 9. So then we can write the complex number as 2 over 13 minus 3 over 13i. See? Just break it up. 2 over 13 minus 3 over 13i. And there's how we can, that's how those operations work. So just a little review over the complex numbers.